Hello, this is Mr. Collier, and today we're doing inverse functions. Okay, here we have some mapping diagrams of functions. So this function is basically a table of values with x and y, and it maps 1 to 3, and 2 corresponds to 4 with the rule plus 2, right? So the inverse of that, of going from x plus 2 gives you y, is going backwards, is subtracting 2, obviously. Okay, that brings us back to the original numbers. 3 minus 2, 4 minus 2, 5 minus 2, etc. If we have this relationship over here, times 2, then the reverse of that is divide by 2, or the inverse is divide by 2. And cubing, the reverse of that is, or the inverse of that is cube root. Okay, so we're going to be looking at inverse functions today. We can write a function for each of these things up here. And let me separate it into 3. So this function here is the function f of x equals x plus 2. The next one is f of x equals 2 times x. And the third one is f of x equals x cubed. So that's the function illustrated in each of the diagrams above. Now the inverse, and we use a symbol, it kind of looks like an exponent, but it's not. It's read the inverse of f, or f inverse of x, and it just is the inverse function of f of x. Okay, so this one's plus 2, and then this one's going to be minus 2. So let me write them for those three here above. So f inverse of x is when I'm minus 2. F inverse of x in this case is divide by 2. And f inverse of x in this case here is cube root of x. Okay, let's look at some more function notation, then we'll see some inverse function notation. So f of 4 for each of the three functions is just plugging in 4 for the x value and getting the y value basically. So f of 4 for the first function is 6. F of 4 for the second function, we can see it in the diagram, it's 8. F of 4 for the next function is 64. Okay. Now to get the inverses, so the inverses is just like the reverse, or the inverse of this. This is like x equals 4, y equals 6. So the f inverse of 6 is basically what's the x value when y is 6, and that is 4. Okay, so it's like reverse. And I should have organized this a bit better. Here, f inverse of 8 equals 4. So it's just the other way around. And here, f inverse of 64 equals 4. Okay? So the inverse kind of undoes the effect of the function and gets you back to the original value. That's one way of thinking about it. Okay, let's look at the next page here. So here we have the function y equals, or f of x equals x squared for x greater than or equal to 0, restricted domain. So only this part right here. So let's take a look at f of 2. So if you want to get f of 2 from this, well, just maybe from the graph, you go to where x is 2 and find the y value, and you get 4. Okay, so f of 2, let's just reiterate what that means. It means find y when x is 2. Okay, that's what f of 2 means. Now if you got f inverse of a number, that's swapping the x's and the y's. It means find x when y equals 4. Okay, find x when y equals 4. So f inverse of 4 is, well, we look at y equals 4. Find the x value, it is 2. just the opposite or the inverse of this here, right? So f inverse of 4 equals 2 because when x is 2, y is 4 in our function up here. Now I'm going to draw a picture of a parabola without x greater than or equal to 0. So a parabola without that restriction goes like that, okay? And let's say we've got the point, well, we have the point here at 2, 4. That means we would have another point over here at negative 2, 4 because it's symmetric. So if I were to do f inverse of 4 here, I can't say it's 2 because when, y is 4, x is 2, but also when y is 4, x is negative 2. So there's two answers. So this is not a function. Yeah, f inverse of 4 in this case is not a function. In fact, for all parabolas without restricted domains, it's not a function. Okay, and you can tell graphically too, because it fails horizontal line test. Fails the horizontal line test. If you can draw a line and it hits 2 points anywhere on the graph, it's not one-to-one as we call it, and has no no inverse function. Okay, so that doesn't have an inverse, but this one over here does. It passes the horizontal line test. Okay, that's why we had restricted domain, so it actually has an inverse. Okay, so it's important to remember, if it fails the horizontal line test, it does not have an inverse. Okay, so this here is just indicating the x's and the y's swap in this notation because that's what the inverses do. Let's look at the graph to get f inverse of 9. That means what's the x value when y is 9? So when y is 9, the x value is 3, we can see. When y is 6.25, that looks like it's going to be 2.5. And when y is 3, x is about 1.7. It looks approximately, it's hard to tell from the graph, but about 1.7. Write down an expression for the inverse. Well, we have the equation for the original, it's x squared. So the inverse is just the inverse of squaring, which is square root. Okay, so that's f inverse of x equals square root of x. Okay. I'm going to skip maybe a couple things here. Okay, let's go to this question. Here is the actual formula for changing from Celsius into Fahrenheit. Okay, do 9/5 times Celsius plus 32. Show that the temperature in Fahrenheit when it's 20 degrees Celsius is 68. So I'm just going to do f of 20. That means I'm going to substitute in 20 for c and work that out. That gives me 68. If you type that into your calculator, you get 68 degrees Fahrenheit. Alright, so, and that corresponds to the graph as well. 20, 68 looks correct. Okay, this is the graph of Celsius, which is also called centigrade, by the way, versus Fahrenheit. So if you look at the graph, remember this means, when you have the inverse notation, it means what's the x value when y is 68. So actually that's just what we did. We went across from 68 and we got 20. Okay. Okay, so f of 20 up here is equal to 68. That means f inverse of 68 equals 20. Totally makes sense. Okay, so this means, well, let's just write it in layman's terms. 68 degrees Fahrenheit is equal to 20 degrees Celsius. Okay, rearrange this to make C the subject. Okay, let's check that out. So we can, what's we can do? We can subtract 32, so f minus 32 equals 9/5c. We could multiply by 5 and get 5 times f minus 32 equals 9c. And then c equals, we'll divide by 9. 5 over 9 times f minus 32. That is a formula that if you know Fahrenheit, you can get Celsius, right? Let's check out C68. That is just substituting in 68 here. Okay, so 68 minus 32 is 36, and then multiply by that, you do get 20, okay? 20 degrees Celsius. So that means when the Fahrenheit is 68, it is 20 degrees Celsius. So that means it's the same as the inverse, right? Maybe C of f is the same as f inverse, okay? So when you rearrange a formula to get the other variable, then you're basically getting the inverse.